Today we're going to look at more graph shapes. We're going to start with review from yesterday. Warm up. Sketch the following functions and let's identify the domain and range. So the first one, we start at 2 and the slope is 3/4. So here's the y-intercept is 2. A slope of 3/4 means we go up 3. 1, 2, 3 over 4. 1, 2, 3, 4. And I'm going to do that at another time. Up 3 over 4. Oops, did I do that right? Up 3. 1, 2, 3 over 4. Okay, that looks good. And then we'll connect our line here. Okay. Let's talk about the equation. What type? Okay, so it doesn't ask about domain and range. Well, the domain would be all real numbers, and so would the range, because every value of x and every value of y would be on the graph. If it's linear, it's going to look something like this. Y equals mx plus b. And the shape will be a line, a straight line. Okay, let's look at quadratic functions. We graphed this guy yesterday, y equals x squared, and it looks something like this, a U-shaped graph. So we talked about yesterday, if you see an x squared in there, it's a U-shaped graph, an equation. It can be y equals x squared. It can have other stuff in there too. And the shape is U-shaped. Another word for that is it's a parabola. So when you see a parabola, look for that x squared as the highest power of x. Today we're going to look at 3 more shapes of graphs. The first is called the absolute value function. Let's sketch it first. I made a table. I picked some x values. Let's plug in. So the first one, what is the absolute value of -2? What's the distance from 0? It's 2. What's the absolute value of -1? It's 1. How about 0? How about 1? And how about 2? So we take a look at this and we graph it. It looks something like this. And a parabola is a U-shaped graph, but if we take a look at this graph, this is also like a letter, but not like a U. This will be our V-shaped graph. So absolute value, V-shaped graph. So when you see those lines there, V-shaped graph. Let's talk about the domain and range. Domain is all possible x values, and you can see every x value will have an answer on your graph. So we say all real, so this is x values. Okay, the range though, if you take a look at the range, there's nothing below 0, so y is greater than or equal to 0. The vertex is where it changes direction, and that's at 0, 0. Okay, so V-shaped graph if you see the absolute value lines. Okay, try graphing these on your calculator. Are they also all V-shaped graphs? Well, let's try it. So I'll pull up my calculator. It takes a second to pull up. Okay, so I'm going to go to my graph. And absolute value, there's this book symbol. It's the one to the button to the left of that. Here's absolute value. And let's type in the first one, x minus 3. What shape is this graph? It's also a V-shaped graph. It's shifted 3 to the right. So let's draw that, sketch that. Looks something like this. How about this one right here with a negative? Does that change the shape of the graph? So I'll hit tab and I'll go up and change this one. And there's a -2 on the outside. And on the inside it's just x. And then on the outside of the absolute value sign we have a +5. Does that change at all? It does, but it's still a V-shaped graph. So if I were to sketch that, it looks something like this, I think. Yep. Okay. So absolute value functions, what shape are they? Well, they are V-shaped graphs. So if you can remember that with an x squared, they're U-shaped. In absolute value, they're V-shaped graphs. You'll be good. Okay, let's look at exponential functions. Let's say you have $1. You win a contest where they double the amount you have the first day, and each day thereafter fill in the following table. So the first day we have $1, the next day we have 2, the next day 4, the next day 8, 16, 32, and so on. Let's graph this on the calculator. Here's the equation for it. We start with 1 and it doubles every time. So again, I'll hit tab, delete this one. So we have the 1 and then the parentheses 2 to the power of x. Let's graph this. And we can see we start with the 1 and it doubles every time. So this is growing really quickly. This is called exponential growth. Sketch that graph below. Graph and sketch each of the following functions below. Let's do 3 to the x, 3 to the x plus 5. Let's see what those look like. Okay, so I'm going to hit tab. Let's do 3 to the x first. Actually, I'm just going to type it in here so we can compare it. So here's 3 to the x. It's even steeper. Let's do 3 to the x plus 5. And that one looks the same, but it's shifted over to the left 5 units. So if we were to graph these, here's 3 to the x, pretty steep. And the other one's the same, but it's shifted over. What shape are exponential functions? Well, they start out slow, growing slowly, but then very quickly. So start out pretty slow, but then they grow really fast. Excuse me, last shape, cubic functions. Okay, let's sketch in these guys and see what they look like. So I'm going to clear this. Okay, type in the first one, which is x to the third power. Okay, x to the third power. Okay, here's what it looks like. So if I sketch this, use this, starts out low and then it goes high. And let's try the next one. Okay, this one's longer. Let's hit tab. Go up. Okay, so we have x to the third plus 2x squared minus 5x minus 6. Okay, so this one's still kind of wobbly like that. So if I were to graph that, it looks something like this. Okay, so if you had to describe what shape are cubic functions, well, they kind of are wobbly. They don't look like any of the other graphs. You can say that they go up, and then there's some turning points, and they go up again. Okay, the following is a cubic function. Okay, so here's the one we just graphed. Locate the following. So here's some vocab we have to know. Absolute minimum. The absolute minimum we don't know because it keeps going down forever. So here we don't know, but it's the smallest the graph can be. And here there's no absolute minimum. The absolute maximum is, of course, the biggest the graph can be. And here there's no absolute maximum for this one. The local minimum is look at your graph in that region that you can see what's the minimum. And so we can see this minimum right here. It is, if you find this coordinate, 2 over and 4 down. So 2, negative 4. So the local minimum, it's in the region that you can see. So this is what you can see. And then the local maximum in this region, here's the highest point that we can see in this region, and it's negative 1, 8 is the local maximum. So there can be absolute mins and maxes. So for example, the absolute minimum of a parabola, this parabola would be 0, 0. If I flipped it, that could also be the absolute maximum. And here, there would be no local min or max, it's just absolute. So we're going to practice some of these words and look at the shapes of these graphs today, and then we'll review tomorrow.